The alternator is a machine that converts mechanical energy into electrical energy. Patrick's Garage. In the Volvo 140 series, a Bosch alternator is used as a part of charging system. Its function is to supply the electrical consumers with current and to keep the battery charged while the engine is running. The battery alone isn't efficient to power the vehicle for long periods of time. Its storage capacity is limited, and it would become discharged quickly if it were the only source of electricity. The alternator, driven by the engine crankshaft through a belt, continually generates electricity whenever the engine runs. The alternator operates the principle of electromagnetic induction. When a conductor cuts across magnetic lines of force, and electric current is induced in that conductor. In a Bosch alternator, the magnetic field is not stationary. Instead, the field rotates. The rotating field is produced by the rotor. The stationary part containing the conductors is the stator winding. As the rotor spins, its magnetic field sweeps through the stator windings. Alternating current, or AC, is induced in those windings. In older cars, direct current generators were used. In such generators, the armature rotates inside a stationary magnetic field. The alternator works differently. Here the field rotates and the armature conductors remain fixed. This design allows higher output, lower speeds, reduced weight, and greater durability. For these reasons, alternators replaced old direct current generators in most cars beginning in the 60s. The rotor consists of claw pole assembly with a field winding wound around an iron core. Current is supplied to the field winding through two slip rings and brushes. When current passes through the rotor winding, a magnetic field is created. As the rotor turns, this magnetic field also rotates, cutting across the stator windings and inducing the alternating current. The stator is a stationary iron core with 3 sets of windings arranged to produce 3-phase alternating current. As the rotating magnetic field passes, each winding voltage is induced. The 3-phase system ensures a smooth and continuous output of current, which is more efficient than single-phase generation. Automotive electrical systems require direct current. Alternating current cannot be used to charge the battery. For this reason, the Bosch alternator contains a set of rectifier diodes. A diode allows current to pass in only one direction. By arranging 6 diodes in a bridge, the 3-phase alternating current from the stator is converted into direct current. The rectified current then flows to the battery and to the electrical consumers of the vehicle. In addition to the 6 main rectifier diodes, Bosch alternators also contain 3 smaller auxiliary diodes. Their function is to provide current to the rotor field winding after the alternator has begun to generate electricity. This arrangement makes the alternator self-sustaining. Once it is running, it no longer depends solely on battery current to excite the field. Alternator is capable of producing higher voltage than the vehicle can use without control. System voltage would rise excessively, leading to overcharging of the battery and damage to lamps and electrical components. To prevent this, a voltage regulator is connected in series with the field winding. When system voltage reaches the specified limit, the regulator reduces or interrupts the current supply to the rotor field winding. When voltage falls, the regulator allows more current to flow. In this way, the regulator maintains system voltage at approximately 14 volts. When the ignition switch is turned on, current flows from the battery through the charging warning lamp, through the regulator, and into the rotor field winding. This small current establishes the initial magnetic field necessary for generation once the engine is started and the alternator begins to run. The stator windings produce alternating current. The rectifier diodes convert this current into direct current, which charges the battery. At the same time, part of the output is fed back through the auxiliary diodes to maintain current in the field winding. As engine speed increases, alternator output rises. The voltage regulator continuously adjusts field current to maintain the proper charging voltage. The Bosch alternator in the Volvo 140 series function as follows. The rotor produces a rotating magnetic field. The stator windings generate three-phase alternating current. The diodes rectify this current into direct current. The auxiliary diodes supply field current to sustain operation. The voltage regulator maintains constant system voltage. By this process, the alternator converts mechanical energy from the engine into electrical energy. It ensures that the battery remains charged and that all electrical devices operate reliably. The alternator is one of the most important components of the vehicle's electrical system. Without it, the battery would soon be discharged and the vehicle could not continue to operate. The Bosch alternator used on the Volvo 140 series is efficient, durable, and an essential part of the charging system. I'll catch you in the next one on Saturday, 11 a.m. Eastern Time, 8 a.m. Pacific Time. And if you haven't subscribed to the channel yet, please do. Click the subscribe button and notifications bell so that way you can be notified as soon as I upload new videos about car repairing.